All right, we're going to go over how to calculate the efficiency of a mechanical system. So what I've given you here is some data for the system. What the system is, it's a winch. The winch is being tested with two different loads. So the first load is 7,000 newtons, the second load is 11,000 newtons. And we're going to see the difference in efficiency when lifting 7,000 compared to 11,000. The distance we're lifting is 24 meters. And then we have our electrical information. And so we have the voltage, the current, and the amount of time it took to lift the load 24 meters. And we have that for both examples. And so the first thing that we're going to need to do is calculate the work in the system. And so the work being done by the system is equal to the force times the distance. So we're going to go ahead and calculate that for...
Alexis Smith, please come to the office. Alexis Smith, please come to the office.
We're going to go ahead and calculate that for both of the weights. And so our first weight was 7,000 newtons. We're going to time that by the distance of 24 meters. So when we do that, we get an answer of 168,000, and the unit, a newton meter, is called a joule. And so we have 168,000 joules for weight number 1. For weight number 2, when we're calculating the work, we have 11,000 newtons, again times our 24 meters. And so when we calculate that one, we get 264,000 joules of work. Again, a newton meter is a joule. All right, the next thing we need to calculate is the power out. Power out is equal to the work out divided by time. Okay, and so our work out was 168,000 joules. Our time that it took to lift weight number 1 was 360 seconds. And so if we do that calculation, 168,000 divided by 360, we get about 467, and that is watts of power. Joules per second is equal to a watt. 467 watts. Okay, that's for weight number 1. For the second weight, we take our number 264,000 joules divided by the time. It took 720 seconds. So 264,000 divided by 720, and we get 367 watts of power is what we're getting out of our system. All right. Now we have to calculate what we're putting into the system. And so if we think about a mechanical system that's run on electricity, what are we using to power it? We're using electricity to power it. So power in is equal to current times voltage. And so for weight number 1, our current that we're getting is 100 amps. Our voltage is 12 volts. And so the power we're putting into our system is 1,200 watts of power for weight number 1. The power we're putting into our system for weight number 2, the current 160 amps, the voltage is 12 volts. And so we multiply those two numbers, and we get 1920 watts we're putting into this system. All right. And so once we have those calculated, we have power output and power input, we could calculate efficiency. And so efficiency of the system is equal to the power out divided by the power in, and we'll multiply that by 100 to get it to a percent. So the power out of this system was 467 watts. The power in was 1200 watts. We'll multiply that by 100 again to get our percentage. And so 467 divided by 1200 times 100, and we get about 39% efficient. So again, the efficiency of our system is equal to the power out divided by the power in, and we'll multiply it by 100 to get it into a percent. The power out of this system was 367 watts. The power we're putting in, 1920 watts times 100. 367 divided by 1920. Get about 19% efficient. And so we can see that our winch is much more efficient if it is lifting the lighter weight, or the 7,000 newtons of force. And so that's a way that you can calculate the efficiency of a mechanical system.